Alright, in this video we're going to be talking about quadratic functions. So first of all, we've discussed how to graph y equals x squared. We know it's a parabola. We know that the vertex is basically the lowest point on the parabola, or if it's a parabola that opens down, it would be the highest point. And so our vertex here is -3, -4. Notice we have x-intercepts and a y-intercept here. These are just some of the key features of the parabola here. We would say this one opens up. That would mean this one over here opens down. So this is the language that we use. There's also an important line of symmetry here. It's called the Axis of Symmetry. And we make it dotted. It just indicates where we have symmetry, and this is the line x equals -3. Remember, x equals a number is always a vertical line. The other thing we could say is, notice we have a minimum value of, remember it's the y value of the vertex, that would be -4 when x is -3. Now basically what that means is, for this function, no matter what you plug in, your output will never be smaller than -4. Now we actually should be able to write an equation for this. We know what y equals x squared looks like. It's a parabola that is here. In fact, we should know the 5 key points for that parabola. And so you can, based on the movement here, you should be able to write an equation for that parabola. Let's see if you can do that. All right, so because the parabola has been moved 3 left, we would want to put a +3 in here. So it's x plus 3 quantity squared. And because the parabola is down 4, we would put a -4 here. So we basically have a vertical shift down 4 and a horizontal shift left 3. And that's about it for this parabola. So over here, I'm going to go ahead and put in the axis of symmetry. Notice that's at x equals 1. Our vertex here is 1, 4. You can see we have a y-intercept again and 2 x-intercepts. We said this one opens down. Go ahead and see if you can write the equation for this function. Alright, so first of all, you should have a minus out front. And then notice, again, the parabola, if it opens down, it would be like this. If it were centered at 0, 0, which, the basic graph reflected would look like this. And then you would move the vertex 1 to the right. So this would be -1. And up 4, so we would put +4 here. All right. So now we're ready, and actually we could say one more thing. We have, notice it's a maximum value of 4, and again that's when x equals 1. So no matter what you plug into this function, your output will never be greater than 4. All right, so now we're ready to summarize. So it says here, graphing for equations in vertex form. So this is the vertex form. The vertex is hk. The axis of symmetry is x equals h. It's always x equals whatever the x value of the vertex is. If our a, the number out front, is greater than 0, then it's going to open up and we'll have a minimum value. It'll be, well, if a is negative, it's going to open down and we'll have a maximum value. We know to find y-intercepts, we let x be 0. Basically, this is the directions for graphing an equation that's in this form. Once you find the y-intercept, which is generally the easiest or one of the easiest points to find, We can use symmetry to find a third point, and we can always find additional points that are nearby if we need to, if we want a more accurate graph. All right, so notice in our example, if I write right above here the vertex form, you can see that the vertex is HK, which is 1 and 4. So basically it's the opposite of the sign here, and it's the same as the sign here for this number here. Now we can always think of this in terms of shifts. We normally start at 0, but we're going to go 1 right and 4 up. And so in terms of shifts, you can get to the vertex. But the other way is just to pick out the h and k values here. H is 1 and k is 4, and that tells you where your vertex is. All right, so let's go ahead and do number 1 down here. What I always encourage students to do is write the vertex form right above or below. So here you can see that your HK is 3 and 8. And again, whatever's in here, it'll have the opposite sign because of the minus in the formula. And whatever's here, it'll be the same sign. Our axis of symmetry is x equals 3. It's always that number there. And this also opens down because of the negative out front. So a equals -2. And so this opens down. So let's graph the point 3, 8. Let's draw our axis of symmetry. At x equals 3. And if you think about it, we know pretty much what this is going to look like. It's going to be a parabola that opens down. You can see there's going to be a couple x-intercepts here. There'll be a y-intercept here, which is what we're going to find next. If we know a y-intercept, we'll know a point on the opposite side using symmetry. So to find the y-intercept, we let x be 0. So basically we find f of 0. So notice this is -2 times -3 squared. Well, -3 times -3, that's going to be 9. We're going to get -18 plus 8, which is -10. And so when we choose x to be 0, we get y is -10. That's our y-intercept. So let's go ahead and put that on there. So if there's a point 3 away from the axis of symmetry on the left, there'll be a point on the other side, 3 away. And you can see we can draw a pretty nice parabola. Whoops, I kind of missed it there. Using those 3 points. Now, you could see maybe 1 and 5, or it could be that those are our x-intercepts. We could find them. I'm not going to do that here, but I will on the next one. All right, so now that we have our graph, we have a few questions of review that we should be able to answer. So domain, well, we know the domain of a quadratic function is always all real numbers. Notice the graph, even though it's going down quickly, it does go forever left and forever right, so there's no left or rightmost point. So it's going to be all real numbers, our most popular domain. For the range, remember we go from the lowest point to the highest point, moving along the y-axis and looking at y values. Well, there is no lowest point, so we'll call that -infinity. And notice we do have a highest point, and the y value there is 8. We do have a maximum value of 8 when x is 3. Let's see, notice the function is increasing, going from left to right. It's increasing, and down here it's decreasing from left to right. Notice the turning point is when x is 3. So when x goes from -infinity until we get to 3, this function's increasing. So starting in negative infinity territory, as x gets closer and closer to 3, notice it keeps increasing. We get to 3, and that's where the function stops increasing. And then now we're decreasing from now on 3 to infinity. Again, because this goes forever right, we can continue on, and no matter how big x gets, this graph will be decreasing. All right, that's it for the first page. So equations quite frequently are not in that vertex form that we were just looking at. And so we need another way when we have an equation that's in this standard form. Now, there's a way to put it in vertex form, and we do that by completing the square. But we won't be using that process. We're just going to use what's called the vertex formula, which is negative b over 2a. So this is a formula that you need to know by heart. It's how you find the x value of the vertex. And again, it's basically done on this general form here and completing the square and changing this to the vertex form that we were working with on the first page. And in fact, there is a formula for y, but it's just easier once we find the x value to just plug that into the function, and that gives us the y value of the vertex. All right, so once we have the vertex, we know the axis of symmetry is x equals whatever the x value of the vertex is. And again, A out front tells us if we're going to open up or down, depending on if we're positive or negative. We'll find a y-intercept. We'll use symmetry to find a third point, and we can always find additional points if we need to. So let's go ahead and do these steps here. I'm going to go ahead and move this down. And you know what? Let me see if I can autofocus this and make it look a little better. All right. So first of all, our vertex, we'll use the vertex formula. X equals negative b over 2a. Of course, a here is 1, the coefficient of x squared, and b is negative 2, that's the coefficient of x. So this is negative b, which is negative 2, over 2 times a, which is 1. Whoops, let me shut off my bells and whistles here. All right. So you can see that we get 2 over 2, and so we're going to get 1 here. So the x value of the vertex is 1. How do we find the y value? Well, let's see. We're going to plug in 1 into the function. So it'll be 1 squared minus 2 times 1 minus 3. That's going to be 1 minus 2 minus 3. Well, 1 minus 2 is negative 1, minus 3 is negative 4. So 1, negative 4 is the vertex. That means x equals 1 is the axis of symmetry. Again, that 1 is always going to come from the x value of the vertex. Because you can see if we're at 1, negative 4, the axis of symmetry is going through x equals 1. In fact, that's the equation of this line, x equals 1, because every point on this line has an x value of 1. Now, because our coefficient of x squared, the a here, is positive, this opens up. And so we already really know what this is going to look like. It's going to look something like this. We can find some x-intercepts, we can find a y-intercept, and use some symmetry, and that should get us a pretty nice graph. Notice finding the y-intercept is going to be really easy here. If we plug a 0 in here, this zeroes out, and this zeroes out, and you're left with -3. And so 0, -3 is your y-intercept. It just comes from that last number. You may recall if you had like y equals 2x minus 4, the y-intercept is 0, -4. It's always that number there. Notice if you let x be 0, y will equal -4. It's very similar here. When you plug in 0, you're going to get that last number there. All right, so 0, -3, that's right there. We know that we'll have a point over here using symmetry. What's that? 2, -3. So that's enough detail to draw a pretty decent graph. But notice we are asked to find the x-intercepts, and we're expecting that we have 2. So let's go ahead and we'll let y equal 0. Remember, f of x is another name for y. And we can factor this. We need two numbers that multiply to -3 that add to -2. Well, it's got to be 3 and 1, and we need the 3 to be negative and the 1 to be positive. Notice -3 plus 1 does give you that -2. Of course, when you multiply, you do get -3. So we get x is 3 or -1. So our y-intercept, our x-intercepts are 3, 0. And -1, 0. So -1, 0, and 3, 0, which is what we would expect. Notice we're 2 away on each side, and so let's go ahead and draw our graph. So what's the domain here? Well, it's all real numbers, just like for any other quadratic function. It goes forever left and forever right. It doesn't have any places where it skips or has a hole. Our range, we do have a lowest point, and the y value there is -4, so we want to include that. That's why we're using a bracket. But there is no highest point, and so we'll say -4 to infinity. Notice we're going to have a minimum value, and it's going to be -4, and that's when x is 1. Notice we're decreasing from -infinity until we get, notice the graph keeps decreasing when x starts way out here, and eventually we get to here, that's where things change. So it's decreasing from -infinity until x gets to 1. Wait, I got that backwards. This is decreasing from -infinity to 1. And then from 1 to infinity, so starting when x is 1, this graph will from now on be increasing. So 1 to infinity. All right, so let's actually, I think we'll stop right there, and we'll have a second video for this section, this topic.